Okay, so I wanted to do a quick little uh, recap of this little Desmos thing I made. I called this the epsilon-delta limit explorer, and we did it a little bit last week, but I wanted to just go over it again more slowly in case you were confused by what's going on. So what is this thing doing? What the hell is the point of this Desmos thing? So what we really want to do with this epsilon-delta limit explorer is we are investigating whether or not the limit as x goes to a of f of x equals L. So that's a statement. We're investigating, is it true or false? So this is a statement. It can be true or false. And the Desmos application is supposed to help us figure out if it's true or false. And what does it mean for it to be true? Well, we said in class that this symbol, it's a long logical statement. It's for every epsilon greater than 0, there exists delta greater than 0 such that f of x minus L is less than epsilon whenever x minus a is less than delta. So it looks really short here because it's written in a shorthand, but the long version of this statement is pretty long and complicated and involves an epsilon and a delta. And the epsilon-delta limit explorer is supposed to let you play around with the epsilons and deltas as little sliders and figure out whether or not this thing is true or false. So the example I did in class, was the example where f of x is 3x plus 1, a equals 2, and L equals 7. So what we're really talking about is this limit, the limit as x goes to 2 of 3x plus 1 equals 7. Is that a true statement or a false statement? Is it true or false? And we actually know already from chapter 3 that it's going to be a true statement, but in chapter 4 we really want to know what does it mean for it to be true, and that's what we're investigating. Okay, so what does this look like in the Explorer? So this thing equals 7. This means for every epsilon greater than 0, there exists delta greater than 0 such that f of x minus 7 is less than epsilon whenever x minus 2 is less than delta. So that's what it means. What does that look like in the Desmos? So here's the f of x is 3x plus 1, a equals 2, and L equals 7. The epsilon slider is this EP thing. And the point is that what we have to investigate is no matter what value of someone, no matter what value of epsilon somebody gives us, so they could give us any value they want. They could give us 2, they could give us 0.33, they could give us 0.08. No matter what value they give us, we have to be able to find a value of delta so that as long as we're within delta units of x equals 2, this vertical line, the function will live inside this green zone. So the green zone is what the enemy gives us. They give us epsilon, and we have to find delta that makes the function live in the zone. The way the Desmos thing is set up is when you make delta very small, the function deletes itself outside of the region where x is within delta of 2. So by making delta very small, here I can make it even smaller, you sort of get a little piece of the function. And what you want to do is you want to slide delta small enough to always be within the green zone. So the question is, does the limit equal to 7 or not? Is it a true statement or a false statement? And it's a true statement if no matter how you set this epsilon slider, it's always possible to make the green slider fit into the zone. So do we think it's true or not? Let's do a thing. So some people in the chat said, maybe somebody in the chat says 0.35, and you say, okay, well, that's no problem. I just make delta 0.09 and it works. And then someone in the chat says, well, what about 0.18? And then you say, no problem, I'll just make delta that small. See, because look, now the function is entirely within the green zone. And then someone says, oh, well, what about delta equals, okay, 0 is not allowed, but let's do 0.07. You say, aha, then I'll just zoom in even more. What if I do delta equals 0.01? Well, that seems to work. So whether or not this is a true statement or a false statement is a statement about if for every possible value of epsilon, we can find a value of delta so that the piece of the function within delta of x equals 2 lives in the zone that was specified within epsilon of L equals 7. So that's what it means, and that's how the explorer works. To give you another example, so in the example that I just gave you, we know that the answer was true and it looks plausible, right? We can always, no matter how small epsilon is, if I slide delta to be even smaller, then eventually it'll work out. So even delta equals 0.01, if I make delta teeny tiny, let's start with 0.01. If I make it even tinier, eventually it'll work out. Let's see, how small do I need to make it? So about that works. So the Explorer kind of helped us figure that out, and we also did it in class using inequalities and like logical statements, which is the ultimate proof. To give you another example, let's do this. Let's investigate the limit as x goes to 2 of 3x plus 1 equals 6. So we know this is a false statement. We know this is false. But let's see what does that look like in the epsilon-delta explorer. What does that look like in the epsilon-delta explorer? So here I'll put L equals 6. And let's play with some epsilon values. Let's make delta something reasonable again. So now we're zooming in around 6. And let's see what values of epsilon work. So if we make epsilon really small, so if epsilon is that small, is there any single value of delta that works? Well, it doesn't look like it, because when you make delta really small, you don't live in the zone at all. So because there's no value of delta here that makes you live in the green zone, which is zoomed in around 6, that means that the limit is not equal to 6. So in this case, we said this one is false, because if epsilon is small, then no matter what delta is, we don't live in the green zone. Okay, so hopefully that helps you figure out how this explorer works, and I think you could try it for a number of examples. You can type in any f of x you want, and indeed the hard problem of the day is about the function sine of 1 over x, and it's about the point a equals 0, and you can start by trying to show that the limit is not 0. So you would zoom in on this to do the hard problem of the day, and you would say, okay, what if we shrink delta enough, do we eventually live in the green zone or not? Do we eventually live in the green zone or not? Why or why not? And can you convert that into something mathematical? This is, by the way, this is that crazy function we saw on the first day of class that kind of oscillates faster and faster and faster as you get really close to 0. Okay, I'm going to stop there. Hopefully that helps.